Hello everyone, welcome to this session on CET chemistry. So in this session, we'll be discussing some of the CET pattern questions from this chapter called Some Basic Concepts in Chemistry. And we'll specifically emphasize on this mole concepts from this chapter. So let us look at some of the questions one by one and answer them accordingly. So basically, when you look at this chapter, it constitutes approximately to 5% in the total CET weightage, as you can see in the slide. So and when you say 5%, approximately it constitutes two questions. And some of the important subtopics that we could focus on are mole concepts, percentage composition, uh, molality, gas loss, empirical formula, and molecular formula. So these are some of the important subtopics which we can emphasize on. So let us look at the questions one by one and answer them accordingly. Okay, so the first question is this. An organic compound contains carbon with 40%, hydrogen 13.33%, and nitrogen 46.67%. Its empirical formula is, so we have to calculate the empirical formula with the given composition. So whenever these kind of questions are given, always ensure that whatever percentage they have given is equivalent to 100%. So then from that you can say whatever is the percentage given, so it is nothing but equivalent to that many grams. So let us calculate the total percentage so that we can say 100% these are the elements which are present in the given compound. So if you add them up, so it's 40 plus 13.33 plus 46.67. So when you look at when you add them up, it's coming to 46.67, 47, 50, 60 plus 40, 100. So 100%. So no worries. So you can say whatever is whatever elements are present in the sample, the percentages of the respective elements are given here. Here. So how do you calculate the empirical formula? So first always calculate the number of moles and then find out the simple whole number ratio. So that will give you the simple whole number, that will give you the empirical formula. So let us try to solve this question first. First step is number of moles of carbon. So number of moles of carbon. So you can say if you say 40%, it is nothing but 40 grams out of total 100%. So you can say 40 number of moles is nothing but mass by molar mass. So 40 is the mass given present in the sample divided by molar mass of carbon is 12. So number of moles will be 40 by 12. So if you calculate 40 by 12, so it's coming to 3.33 per and so on. And if you calculate the number of moles of hydrogen, number of moles of hydrogen is equal to 13.33 divided by molar mass of hydrogen is 1. So you can take it as approximately 13.33. Then let us calculate the number of moles of nitrogen. So the mass is 46.67. 46.67 divided by mass of nitrogen is 14 molar mass. So if you calculate the value, so 46.67 divided by 14. So it's coming to around 3.333 once again. Now let us find out the simplest whole number ratio. So how to do that? You just divide whichever is the smallest number from the given values. So here it is 3.33 and 13.33, 3.33. So 3.33 will be the smallest number. So divide every element, every value with the smallest number. That will give you the simplest whole number ratio. So that will be, so so for carbon, it will be 3.33, whatever, 3 by 3.333. For hydrogen, it will be 13.33 divided by 3.33. And for nitrogen, it will be 3.33, whatever, 33 by 3.33. So this goes off, it's approximately 1. This also goes off, so it's approximately 1. And if you calculate 13.33 divided by 3.33, 13.33 divided by 3.33. So it's coming to approximately 4. So now from this we can find out the simplest ratio, which is nothing but C1 and H4 and N. So this will be the empirical formula. So the answer from the given options can be, answer from the given option is CH4N. So that will be the answer for the first question. So the way is very simple. So first find out the number of moles and then take the simplest number and then divide all the numbers with that number. Then you get the simplest ratio. So that will be the empirical formula. Let us look at the next question. So the number of oxygen atoms in 4.4 grams of carbon dioxide is, so we have to find out how many oxygen atoms are there in 4.4 grams of carbon dioxide. Now, if you say 1 mole of carbon dioxide, so it is nothing but equivalent to carbon is 12 and oxygen is 32, so it's nothing but 44 grams. So it is nothing but equivalent to molecular weight, whatever. And whenever you say 1 mole, it is equivalent to 6.023 times 10 power 23. So if you say molecules, it will be molecules. If you say ions, it will be ions, whatever. So it's just a unit. Now 44 grams is equal to these many molecules. Now, so we have to find out how many moles of molecules will be present in 4.4 grams. So 4.4 grams will have how many molecules? So it will be 4.4 divided by 44 multiplied by 6.023 times 10 power 23. So it will be times 10. So it will be equivalent to 6.023 times 10 power 22 molecules. So these many molecules of carbon dioxide are present. Now the question is number of oxygen atoms. So we have to calculate the number of oxygen atoms. So if you take one molecule of carbon dioxide, it has 2 oxygen atoms. 2 oxygen atoms. Now if you take 6.023 times 10 power 22 molecules of carbon dioxide, so it is equivalent to how many oxygen atoms? So obviously it will be 6.023 times 10 power 22 times 2. So it will be approximately, so this you can take it as 6 to the 12, so it will be 12 times 10 power 22. And 10 power 12, 12 power 22, no option has this answer. So if you multiply 10 by 10, so it will be 1.2 times 10 power 23. So if you look at the first option, it is equivalent to that. So from this we can say A will be the answer. Let us look at the third question. 3.3 grams of inorganic organic compound containing carbon, hydrogen and oxygen on combustion yields 0.44 grams of carbon dioxide and 0.18 grams of water. If 1 mole of compound weighs 60 grams, then the molecular formula of the compound is. So first, let us find out the empirical formula. So from that, you can calculate the molecular formula. So let us try to answer it. Now, so the in the question they have given 0.44 grams of carbon dioxide and 0.18 grams of water will be obtained when you combust this 0.3 grams of organic compound. So how do we solve this question? So if you say 1 mole of carbon dioxide, 1 mole of carbon dioxide is nothing but equivalent to 44 grams. So if you take 44 grams of carbon dioxide, so in that how much of carbon is present? So it will be obviously 12. So because carbon is 12 and two oxygens are 16, 16 to the 32. So it will be equal to, it will have 12 grams of carbon. Now, if 44 grams of carbon dioxide contains 12 grams of carbon, 44 grams of carbon dioxide contains 12 grams of carbon. So 0.44 grams of carbon dioxide will contain how much of carbon? So you can solve it. So it will be 0.44 divided by 44 multiplied by 12. So it will be equivalent to, so if you multiply this by 100, so it becomes this, and it is equivalent to 0.12 grams. 0.12 grams of carbon is present in the given organic compound out of 0.30. Now, basically they are combusting this organic compound and you are getting carbon dioxide and water. So whenever you say combustion, it is nothing but you have CXHY, we don't know the organic compound, plus oxygen reacts to form carbon dioxide and water. So you have oxygen also coming from outside. Okay, but whatever hydrogen is present, so that can be seen as water in the end product. Now, whatever hydrogen is present in the sample, so it is equivalent to the amount of hydrogen present in the water. Now, let us solve for hydrogen. So if you say 1 mole of water, it is equivalent to 18 grams of water. And if you take 18 grams of water at any point of time, it will definitely have 2 grams of hydrogen. Now, if 18 grams of water contain 2 grams of hydrogen, now 0.18 grams of water will contain how much of hydrogen? So that will be 0.18 divided by 18 times 2. So once again it is 100. So it will be 0.02 grams of hydrogen. So total mass of the organic compound is 0.3. So we know carbon, we know hydrogen. So obviously if you subtract carbon and hydrogen from 0.3, you will get the amount of oxygen present in the sample. So let us do that. So total is 0.3. So it will be carbon is 0.12 plus 0.02 plus X, that is for oxygen. So it is equivalent to 0.3 grams. Now, so what will be the X? X will be nothing but amount of oxygen present in the sample, you can say. So X will be equivalent to, so you can say 0.3 minus 0.14. So it is equivalent to 0.16 grams. 0.16 grams of oxygen is present in that sample. So these are the values which we have to remember. So 0.12 grams of carbon, 0.02 grams of hydrogen, and 0.16 grams of oxygen. So from this, you can calculate the empirical formula. So let us try to do that. So 0.16, 0.02, 0.18, 0.2, 0.3. So that is fine. So you are getting 0.3. So you are on the right track. Now let us find out the molecular formula. Sorry, empirical formula. So for simplicity, I'll write down the values here: 0.12 grams of carbon and 0.02 grams of hydrogen and 0.16 grams of oxygen. Okay, let us calculate the number of moles. So number of moles of carbon is equal to mass is 0.12 divided by 12. So it is 1 by 100. So it's approximately 0.01. And similarly, let us calculate the number of moles of hydrogen. It is equivalent to 0.02 divided by 1. It's nothing but 0.02. Let us calculate the number of moles of oxygen. Number of moles of oxygen. So it is equivalent to 0.16 divided by 16. So once again, it is equivalent to 0.01. So now let us calculate the ratio. So carbon is 0.01 and hydrogen is 0.02 and oxygen is 0.01. So you can say the simplest ratio will be CH2O. Now, how to calculate the molecular formula? So you have a formula, this molecular formula mass. Molecular formula mass is equal to empirical formula mass multiplied by N. So molecular formula mass is given in the question. So it is 60. So 60 is equal to empirical formula mass is this. So CH2O will be 12 plus 2, 18, 12 plus 2, 14 plus 16. So it is 30. 30 times N. So your N will be 60 by 30. So it is equivalent to 2. So it's basically CH2O N. So your N is nothing but 2. So CH2O 2. So it is equivalent to C2H4O2. So this will be your molecular formula. C2H4O2. So if you look at the option, D will be the correct answer. So that's how we calculate the molecular formula of a compound. Okay, let us look at the next question. What amount of dioxygen in grams contains 1.8 times 10 power 22 molecules? Now, if you say 1 mole of O2, dioxin is nothing but O2, it is equivalent to, so each oxygen is 16, so it will be 32 grams. So 32 grams is nothing but molecular weight, and whenever you say 1 mole, it is nothing but 6.023 times 10 power 23 molecules. Once again, oxygen is a molecule, so these many molecules. So if 6.023 times 10 power 23 molecules constitute 32 grams, so what will be the mass of 1.8 times 10 power 22 molecules? That's the question. So let us try to answer it. So is equal to 1.8 times 10 power 22 molecules. So it is equivalent to how many grams? So it will be 1.8 times 10 power 22 divided by 6.023 times 10 power 23 times 32. So this approximately you can round it off to 6. So it will be 6. So you can say this is like 6 3s are 18. So 0.3 and 0.3 times 32 will be how much? Let us calculate that. 0.3 times 32. So I'm getting 9.6 times. So 10 power 22, 10 power minus, if it goes up, it becomes minus 1. So it will be 10 power minus 1. So it is nothing but 0.96 grams of dioxygen will constitute these many molecules. So let us look at the options. So 0.96 is the B option. So B will be the answer. So that's how we solve these questions. Let us look at the next question. So 10 grams of a mixture of barium oxide and calcium oxide requires 100 cm³ of 2.5 molar HCl to react completely. The percentage of calcium oxide in the mixture is approximately. So they have given you the molar mass of barium oxide. So we have to find out the percentage of calcium oxide. Okay, let us look at this question and answer it. So from the given values, you can always first, whenever these kind of questions are given, if you can write the equation, so that will give a better understanding. So here HCl is reacting with barium oxide and calcium oxide. So whenever you say metal oxides, they are basic. So obviously whenever something is basic, it will react with acid to form salt and water. That we know. So let us try to write an equation. So barium oxide plus calcium oxide plus HCl gives rise to salt and water. So it can be CaCl2 plus BaCl2 plus water. So you have to balance the equation. So on the right, 4 chlorines are there. So you just put 4 here and 4 hydrogens on the left. So you can just put 2 here. So 2 oxygens on the left, 2 oxygens on the right. So it is balanced. Now, the molar ratio is so when you don't write anything, it means there is 1 and there is 1 here. So if you take 1 mole each of barium oxide and calcium oxide, which is nothing but 2 moles, you can say, it will react with the 4 moles of HCl. So that is the ratio. You can say 2:4 or 1:2. So from this, we can find out the ratio of number of moles of BaO and CaO that can be present in the sample, if we know the number of moles of HCl. From the values given here, you can calculate the number of moles. So let us try to do it. So we know molarity is equal to number of moles by volume in liters, or you can say number of moles multiplied by 1000 by volume in cm cube or ml. We know 1 liter is nothing but 1 dm cube, which is nothing but equivalent to 1000 cm cube, and 1 cm cube is always equal to 1 ml. So these are some of the conversions which we have to remember. Now let us try to answer this question. So molarity is given, so it is nothing but 2.5 is equal to number of moles. We have to find out X multiplied by 1000 by V in cm cube. So it's nothing but 100. So zeros goes off. So X is equal to 2.5 by 10 is nothing but 0.25 moles. So you have 2.25 moles of HCl. So from the ratio, you can say how many moles of barium oxide and calcium oxide are present. So if 4 moles of HCl are present, so it will react with 2 moles of mixture of barium oxide and calcium oxide. So similarly, if 0.25 moles of HCl are present, so its ratio is like 2:4. So it will be basically half of this. So now from this you can say the total number of moles of barium oxide and calcium oxide can be half of that 0.25. So which is nothing but equivalent to 0.125. So you can say that. So barium oxide and calcium oxide together, the number of moles will be 0.125 moles. Now we have to calculate the percentage of calcium oxide, given that the total mass of the mixture of barium oxide and calcium oxide is 10 grams. Now, how do we calculate this? So how to calculate the number of moles of barium oxide and calcium oxide? It is like this. So it's mass by molar mass once again. So let us say the mass of calcium oxide is X. Obviously, barium oxide has to be 10 minus X. Now let us try to solve this question. So number of moles of barium oxide will be mass, which is 10 minus X, divided by molar mass is 153, which is already given here. Molar mass of barium oxide 153, and plus number of moles of calcium oxide. So it will be X by molar mass of calcium oxide will be 40 plus 16, 56. So it will be 56 is equal to total mass is given in the question as 10 grams, but from the equation we should know that the total number of moles should be equivalent to 0.125. So let us equalize it to 0.125. So 0.125 moles. So let us solve the value for X. So it will be 153 times 56. So it will be 56 times 10 minus x plus 153x is equal to 0.125. So from this you can say 56 times 10 minus x plus 153x is equivalent to your 0.125 times 153 times 56. So when you solve for this x, so it becomes, therefore, so x will be approximately equal to, you can solve it, and it will approximately come to 5.26 grams. 5.26 will be the x value. So x, which is nothing but calcium oxide. So that's what we considered. Now from that you can calculate the percentage of calcium oxide. So how to do it? So calcium oxide mass is 5.26. So percentage will be, so percentage of calcium oxide will be equivalent to 5.26 divided by total mass. Total mass is given here in the question, which is 10 grams. So out of 10 grams, how much calcium oxide constitute? So it will be 10 multiplied by 100. So this goes off. So it's approximately equal to 52.6%. So from this we can say that option C will be the correct answer. Okay, let us look at the next question. The mass of 112 cm³ of ammonia gas at STP is how much? So we should know that 1 mole of any gas at STP will occupy 22.4 dm³, or you can say liters, because 1 dm³ is nothing but 1 liter. So if you want to convert this into cm³, so it is equivalent to 22.4 multiplied by 1000. So that will be equivalent to cm³. So it will be 22400 cm³. So 1 mole of any gas at STP will occupy this much volume. So that is standard. So when you say STP, it's nothing but standard temperature and pressure. So standard temperature is 273 Kelvin, which is 0 degrees centigrade, and 1 atmospheric pressure will be the pressure. Now, so if 22,400 cm³ is nothing but 1 mole. So you can correlate the values to the given question. So from this we can say that 1 mole of ammonia, so which is equivalent to its molar mass. Molar mass of ammonia is, this is 14 and 3. So it will be 14 plus 3, it will be 17. So ammonia is equal to 17 grams, which is its molecular weight, is equivalent to 22,400 cm³. So if 17 grams occupy this much cm³, so 112 cm³ will constitute how much in grams of ammonia? So we can solve this. So therefore 112 divided by 22,400 multiplied by 17, so is equal to how much? Let us calculate this. So 112 multiplied by 17 is equal to this much divided by 22,400. So I'm getting 0.08085 grams. So this much of ammonia will constitute this many ml. So the answer will be 0.085. So that will be the answer for the 6th question. Let us look at the next question. A signature written in carbon pencil weighs 1 mg. What is the number of carbon atoms present in the signature? Now, when you say carbon or whatever pencil, it's mostly graphite, and graphite is nothing but carbon. It's made up of carbon. So from this we can say that, so 1 mole of carbon is equal to its molecular weight, which is 12 grams. It is equivalent to 6.023 times 10 power 23 atoms of carbon. Because we are discussing element, so you have atoms. So these many atoms will constitute 12 grams. So 1 milligram will constitute how many atoms? That's it. That's the question. So 1 milligram is nothing but, 1 times 10 power minus 3 grams. So is equal to how many atoms? Therefore, so 1 times 10 power minus 3 divided by 12 multiplied by 6.023 times 10 power 23. So to make it simple, let me equalize this 6.023 to just 6. So it will be 6 times 10 power 23. So it will be 6 2s are 12. Then it will be 1 by 2 is nothing but 0.5 times 10 power 20, because 23 minus 3 will be 20. So let us look at if we have an option. Yeah, you have an option 0.502 times 10 power 20. So B will be the answer. So that's how we solve these kind of questions. Let us look at the next question. 6.84 grams of sucrose is dissolved in 200 grams of water. The molarity of the solution is. So to calculate molarity, we should know the formula. So molarity is nothing but mass of solute by weight of solvent. Weight of solvent in kg, in kilogram. Or you can say mass of solute multiplied by 1000 by weight of solvent in grams. So weight of solvent in grams. So it is nothing but mass of the solute is given in the question. Mass of solute is nothing but 6.84. So solute is nothing but which is present in lesser amounts. Solvent is something which is present in higher amounts. So sucrose will be the solute and water will be the solvent. So you can just substitute the values. So it will be mass of the solute is 6.84 times 1000 by weight of the solvent in grams, which is nothing but 200 grams of water. So let us substitute that. So it will be 200 grams here. This goes off, 2 5s are 10. So it will be 6.84 times 5. Let us calculate the value. 6.84 multiplied by 5. So it will be 6.84 is sucrose multiplied by 1000 by weight of the solvent in grams. So it will be 200. This goes up to 5. So I'm getting. Sorry, so the formula here should be not mass of solute, number of moles of solute. So it will be number of moles of solute. Number of moles of solute. So it's nothing but mass of the solute by molar mass. By molar mass of solute. So which is nothing but mass of the solute is 6.84 divided by molar mass of solute, which is nothing but sucrose. Sucrose is C12H22O11. So it will be 12 times 12. So 120 plus 24, 144 plus 12 plus 22, right? Because hydrogens are 22, and 11 times 16. So that will be the molar mass of oxygen. So it will be 11 times 16. I'm getting 176. So when you add them up, 176 plus 22 plus 144. is equal to 342. I'm getting 342. So that will be the molar mass of sucrose. So it will be by 342. So now when you calculate it, it becomes, so it will be 6.84 multiplied by 5 is equal to 34.2 divided by 342. So I'm getting 0.1 molal. So molality is denoted by the letter small m. Small m. So if you look at the option, C will be the correct answer. So that's how we solve these kind of questions. Let us look at the next question. The mass of glucose to be dissolved in 50 grams of water to get 0.3 molar solution is. So we know the formula. Molarity is nothing but molarity M is equal to number of moles multiplied by 1000 by V in ml. So that will be the, or CM3, whatever. So molarity is given to us, which is nothing but 0.3, and number of moles of glucose. So we can find it out. And the volume dissolved of the solvent, whatever. So it is 50 gram. So we know density of water is 1 gram per dm cube. So density of water is equal to 1 gram per cm cube. So see, 1 ml is nothing but 1 gram. So 50 grams will be equivalent to 50 ml. So in case of water. So let us try to substitute that. So molarity is given 0.3 is equal to number of moles. So number of moles is nothing but mass by molar mass. Mass, let us say it is X divided by molar mass is glucose. Glucose is nothing but C6H12. Sorry, C6H12O6. C6H12O6. So it is nothing but 12 6 are 72 plus 12 plus 16 6 are 96. So it is equivalent to 98, 108, not 10, 180. So it is nothing but 180 grams. So from this we can substitute 180 times 1000 by V in ml of water is nothing but 50. So this goes off 5 to the 10, so it will be 20. So from this we can say X is equal to 0.3 times 180 divided by 20. So is equal to how much? So let us calculate that. So 0 goes off, 2 9s are 18. So it will be 0.3 times 9. So it will be approximately equal to 2.7 grams. So option C will be the correct answer. Okay, let us look at the next question. So the percentage of nitrogen in urea is. So to answer this question, we should know what is the formula for urea. So the formula for urea is NH2CO NH2. And we can calculate the molar mass. So you have 2 nitrogen, so it will be 28 plus, and 4 hydrogen, so it will be plus 4 plus 1 carbon is 12 plus 1 oxygen is 16. So if you calculate this, this becomes 24, 32, 34, 44, 50, 60. So I'm getting molar mass of urea. So molar mass of urea is nothing but 60 grams. So they're asking in that how much nitrogen constitutes. So if 60 grams, let us say it is 100%. So nitrogen constitutes by 28 grams because 2 nitrogen, so 28. So if total 60 grams constitute 100%, so 28 grams constitute how much percentage? That is the question. So it will be 28 divided by 60. Divided by 60 multiplied by 100. So is equal to how much? Let us calculate. So it will be 280 by 6. 280 divided by 6. So I'm getting 46.6% approximately. So the nearest answer could be C, 46. So similarly, you can calculate, this is for nitrogen. Similarly, you can calculate for, let us say, oxygen. So for oxygen, it will be Oxygen is how much? In total, it is 16. So it will be 16 by 60 multiplied by 100. So you can always solve it and you get for oxygen. This is for oxygen. And similarly, you can calculate for hydrogen. So it is 4 grams. So it will be 4 by 60 multiplied by 100. So this will be the percentage for hydrogen. So that's how you can always calculate for each and every element given in the question. So I think that's it. These are the questions. These are some of the questions from this chapter. And these are some of the important formulas which we should remember if you want to solve questions from this chapter. So first is number of mole. So 1 mole, when you say 1 mole of atoms or molecules, it is nothing but 6.023 times 10 power 23. So 1 mole is nothing but this value, 6.023 times 10 power 23. So it can be atoms or molecules or electrons or ions, anything, any species. So 1 mole is always equivalent to that particular number. And next you have number of moles is equal to mass by molar mass. And third is molarity is equal to number of moles by volume of solution in liters. Or you can say if you want to convert this liters into milliliters, it will be number of moles multiplied by 1000 by volume in ml. And the other important law in this chapter is dilution law. So when you dilute a particular solution, what will be the concentration? So initial concentration we say M1 with a volume V1. When you dilute, so the final volume becomes V2 and the final molarity becomes M2. So M1 V1 is equal to M2 V2. And you also have molality. Molality is nothing but number of moles of solute by weight of solvent in kg. And if you want to convert this weight of the solvent in kg, it's nothing but number of moles multiplied by 1000 by weight of solvent in grams. So these are some of the important formulas which we should remember in this chapter. So that's it. If you have any questions or clarifications from whatever we have discussed, you can contact this email info@ctdedu.com, or you can WhatsApp to this number 963 207 4524. Okay, thank you very much. Bye.